All right, thank you very much. A big thanks to the organizers for allowing us to use the space and have this little meeting here. Thank you all for coming. I'll apologize in advance. I'm a little bit under the weather health-wise, so I'll try to be as lucid as possible, and if not, maybe it'll be entertaining at least. So what I'll talk about today, and Ben will hopefully show us some stuff off in a minute, it's basically this concept of web monetization. So we'll kind of dive into what that means. I'll keep it fairly casual. A lot of the slides are ones that I presented in Europe a few weeks ago. But those were both like conferences with many more people, and so I figured this is a chance to not just show some slides, but actually have a bit more of a conversation and kind of answer your guys' questions about, well, how does this work? Where do we see this going, and that kind of stuff. So I'm curious to hear what you guys are thinking about as we go through this. So to start, I want to talk a little bit about what is the problem we're trying to solve, and just to use as an example, not to pick on them or anything, but this is the front page of the New York Times. And you think that New York Times is a news organization, but really, of course, they're an advertising organization. And so the news are what gets people in the door, but then the ads are what actually makes them money. And you can kind of tell that from the front page. So if we just kind of color all the content in green and all the ads in red, there's a lot more red on the front page than there is green. And of course, that's not an amazing user experience. So if I go to the New York Times and I'm looking for the news, there's a lot of like pop-ups and little videos and all kinds of things that play that I may not want to consume. And so as a result, more and more users are using ad blockers. And so this is kind of an exponential growth. And for a while, it kind of looked like it might flatten off because more and more people are starting to use mobile. But then mobile ad blocking started to be a thing, and so now we're right back to sort of exponential growth. And this is increasingly becoming a problem for websites, and so there's been a tremendous number of projects and interest in, well, how do we create like another way for websites to make money? And today I want to talk a little bit about the way that we're proposing and why we think that's the best way. So, as people use more and more ad blockers, the websites are obviously having issues with monetizing. And so this is a fairly strong statement from the CEO of the New York Times in terms of like, hey, if you're not going to look at the ads or if you're not going to pay for a subscription, like you shouldn't even be consuming the news. Like you're not really contributing to their creation. And I mean, being an entrepreneur myself, like I can somewhat relate to that position of like, hey, look, I have to pay salaries, I have to keep these journalists employed. That's not going to happen unless I have some way to make money. And you're basically, by ad blocking, you're cutting that off. And increasingly, the websites are kind of responding by blocking ad blockers. So if you're using an ad blocker, more and more the experience is that, oh, the ads show up again because they came up with a way to bypass the ad blocker, and then they disappear again because the ad blocker got approved, and then they show up again because, and so on. So it's almost like this kind of arms race. But there's a couple of reasons why there shouldn't really be such a problem, because the amount that New York Times is making from you looking at the ads is a lot less than what you might be willing to pay. In fact, on mobile, and this was a statistic that really kind of blew me away, was for a lot of websites, for a lot of news websites, the amount that you pay for your mobile bandwidth, so as part of your total like flat rate or whatever, is actually higher than the amount that the website is making off of you. So if you literally just didn't send any ads, you would save more in bandwidth than the website is currently making. And so I think a lot of people would be like, oh, actually I could save money by paying for the site instead of looking at the ads, at least on mobile. I think that stuff is a little bit different. And so, of course, like as users, some of us realize that we're kind of hurting the webmaster, like the person running the website, by using an ad blocker. And so, at least according to this one survey that we found, a lot of the users of ad blockers actually kind of feel guilty on some level, just because they say like, okay, well, not really supporting those websites. And so just to kind of illustrate what the current situation is, so today we go to a website, we make a request for, let's say, the front page of the New York Times, and we get the news back, but then we got also a bunch of stuff that we don't want. And so very simply, what we would like to do instead is we would like to send some money along with our request, and then hopefully get only the content that we want. And this would actually make both sides happier with the exchange. You know, the website would make a little bit more money, and me as a user, I would get better content without as much distraction. And I mean, advertising is even getting to a point where it's like, you know, if you think about native advertising, it actually injects the ads into the content itself, which has sort of much deeper and much more dangerous implications. So I would say that both sides would be happier with this picture. And funnily enough, like the creators of the web actually foresaw that that could be a thing. And so there is an error code that's reserved for this exact scenario where you've requested a website, the website is not free, and so there's an error code that comes back that says, you know, hey, you should pay. And you know, again, somewhat poetically, in the spec it says, well, this is reserved for future use. And it's been 30 years and it's still reserved. There's no implementation for this yet. And so we were starting to think about, okay, well, what would an implementation for this actually look like? And we think that in order to be sort of a true neutral implementation, it needs some sort of interoperability layer that you can refer to that is itself open. And this is something that, you know, I've been in the blockchain space for about 8 years and change, and I've always kind of been after this sort of holy grail of payments, of like, how do we make payments sort of open and free, and efficient, and cheap, and all the good things that we want. And so the first, the way I see this, so the first hypothesis was, well, if you make the payment system decentralized, then there's nobody to kind of charge you through the nose, and so as a result, it should be open and should be free and it should be very efficient. And then we saw last year, Bitcoin fees went temporarily, but they did go very high, up to like tens of dollars per transaction. You're kind of looking at it and you're saying, like, wait a minute, this is not the kind of very cheap transactions that we at least promise. Like, you know, Fabian and I, who's here actually, we made a video about Bitcoin where we said, look, the fees are lower than PayPal's, and you know, last year they weren't. And so I had to kind of take a step back and say, wait a minute, you know, why is this happening? Or like, what was wrong about our hypothesis? And I think what was going on at a very, very fundamental level was, if you want to keep a system cheap and efficient and so on as it scales, you have to keep making improvements to it. You have to keep making it better. And what makes the internet have that property of getting cheaper and cheaper all the time and faster all the time is because there's constantly people making improvements to it. However, the way that even a decentralized blockchain works, there's actually comparatively little incentive to make it more efficient, because if you're a miner, for example, and you're supposed to support this proposal or that proposal, or you're a company that's using the system, and you're supporting this proposal or that proposal, here we go back. Then you have certain political interests that kind of make it better to support something that helps you. And so from the miner's perspective, for example, higher transaction fees are better. There's some optimum for miners that is higher than the optimum for the users, right? And so it gets, you get into this political, I think the battery might be low on this. You get into this kind of political situation where we have this one system that we all share, and whoever wins the political battle determines the direction. And just to give you like one anecdote of how that sometimes plays out, there was a thread once in the early days of Bitcoin where basically we're talking about whether to have like a Bitcoin foundation. And there were a couple people, including myself, that were very strongly opposed to it because we said there shouldn't be anyone officially representing Bitcoin. That would be sort of centralized, right? That would be against the spirit. It should be this pure community. And of course, very understandably, there were people that said, you know, we should have a foundation. Those were the people that were some of the core developers and things like that who weren't making any salary from working on Bitcoin. They said, like, if there was a foundation, we would be able to get paid. And so the way that it ended up playing out was the second time the people that kind of voted against just happened to be not part of the thread where it was decided to set up the foundation. And so at that point, I kind of learned that you know, these systems are ultimately, you know, like there might not be one person in charge of the system, but it is a political process that governs the whole system. Correct. Thank you. And so I was thinking about that compared to the internet. And with the internet, it is a little bit different because it does have the same property that there is a political process that governs the rules. And so you might say, like, isn't it the same thing? But I think that the difference is how much of the implementation, how much of how the system works is actually specified that everyone has to adhere to. So with Bitcoin, there's a tremendous amount of any blockchain. I'm not picking on Bitcoin, just but with any blockchain, there's a tremendous amount that everyone has to kind of agree on, like how do we sign our transactions, and how is the currency issued, and how do we come to consensus, and all these kinds of things. So we have to agree on all of that. And so if that's if that's the thing that we empower with integrating into it, and if that's the thing that we're making into this big network that has lots of network effects, then it's going to become very valuable to decide which direction that system is going to take in the future. And so with the internet, it's more that most of the decisions are actually left up to you. The internet itself, the internet protocol itself, hasn't changed very much since it was first proposed. And really, the only reason it needed to change at all was because the address space turned out to be too small. And so, I mean, some people from the internet community would hate me for oversimplifying like that, but I think that there wouldn't have been very much traction behind IPv6 if it hadn't been for the address space issue. I'll say it that way. And so what makes the internet so efficient, in my opinion, is that if I'm over here and I can come up with a faster Wi-Fi standard or a faster fiber link or something like that, that immediately has a benefit to me and anyone that I'm connected with and anyone in my environment, and I don't have to convince anyone else to upgrade their stuff. Whereas if I want to make an improvement to Bitcoin, I have to first convince everyone that it's worth the risk. I have to go through a whole political process, and I personally helped go through that at least once, if not twice, where we basically had something we wanted to change, and then kind of took it all the way through to deploying it on the network. And so, yeah, so that's kind of where I'm at in terms of why do we need this sort of interoperability protocol. So a little bit more about Interledger. It's an open protocol. It's a community group at W3C. It's currently the third largest community group after, I believe, WebAssembly and responsive web apps. And there's contributors from a lot of different backgrounds, and not just blockchain people. They're all kinds of people, bank people, payments people, and so on. I think most of the development is happening with a fairly small group of people. Some of them are actually here today, so hopefully you'll go talk to them. And so a lot of this I've covered, but I kind of have some slides to visualize it a little bit. So today, if you think of a blockchain, kind of it's a monolith that has everything. It has the authentication, the currency, everything kind of built into one thing. And so you can build applications on top of that monolith, but then your applications only work within that ecosystem of anyone who's using that blockchain. And so that's, in my opinion, that limits the network effects and it limits the usefulness of any given blockchain application. And so I want to take some inspiration from the internet. I want to say, look, if we build Skype to only work on Ethernet, and if we build BitTorrent to only work on Wi-Fi, and if we build email to only work on token ring networks, we're leaving a lot of value on the table, right? And so what the internet does is it basically abstracts away how data is being moved around and creates an abstraction layer that you can tie into. And so there's a couple of interesting things that does. So number one, if I'm the developer of Skype, I no longer have to build a network stack. I don't even have to choose a specific network stack. I can just say, I'm building on top of the internet, and then you can use it with whatever network stack that you want. That means that if someone comes up with a better network stack, that will be compatible with my application. It also means that if I have two users that are on different network stacks, they can actually interact with each other, right? So I can have a phone call that goes from someone's Wi-Fi connection to someone else's Ethernet connection. And so those are incredibly useful, incredibly powerful things to be able to do. And so the way I think about it with Interledger is it's similarly, it's an abstraction layer, but if you're kind of coming from a blockchain background, you might say, okay, well, what are we abstracting? Are we abstracting smart contracts? Are we abstracting, what is it exactly that we're abstracting? And I would make the case that really the new thing in the blockchain world is the ability to transfer things of value. And specifically, something of value could be something rival rest. So what that means is like I can't, if I have it, you can't have it. If you have it, I can't have it. Which is the opposite of data. Data is like, if I have it, I can make a copy, send it to you, now you have it too. And so that's sort of the fundamental difference between data and money. And so, or like any kind of asset. And so we basically just need something very similar to how the internet works, but for sending the other thing, the thing that's rival rest. And then that should allow us to build smart contracts however we want and so on, and just have them interact with each other by sending each other data and money over those two systems, right? So if I have a smart contract that I want to build, and I want you to be able to interact with it, what should be the case is that it should be able to talk to whatever clients and platforms that you're using the internet and using Interledger for value transfer. So that's kind of the high level idea. How does it work? We're not going to go into too much depth here unless people want to. It's kind of like up to you. But basically, Interledger streams these streams money from one user to another, very similar to how the internet streams data. And again, very similar to the internet, it splits up large amounts of money into small packets, so that if a packet gets lost, we can resend it. It kind of creates a nice user experience. And for us as protocol designers, by splitting it up, we save ourselves a tremendous amount of complexity, because when we first started out, we kind of sent like different sized payments. And if you think about it, like a $10 million payment is processed very differently than a 30-cent payment, right? That you want to, not everyone who can service as a liquidity provider for a 30-cent payment can also service as a liquidity provider for a $10 million payment. And so you would have potentially different paths depending on the size of the packet. You would have the different rules, potentially business rules that affect the packet and so on. And for very similar reasons, that's why the internet doesn't send large files as a single giant internet packet. We ended up splitting it up. And so this turned out to be, in my opinion, one of the bigger insights from this work was to do this. I'm going to skip this part. All right, with that, we're ready for the demo. So we're going to give Ben a few minutes to set up. In the meantime, I'll answer some questions, maybe.
When you split up the payments, do they all execute atomically?
Great question. So the question is, if you split up the payment, do they all execute atomically? So the answer is no. And the way I would defend that decision would be, if you think about it from a perspective of this payment, the system should eventually be good for any use case, right? But it doesn't necessarily have to be good at everything day one. Like for instance, the internet, it went from what's called circuit switching, where you kind of reserve an entire wire between the caller and the person being called on the phone system, and you replace that with the sort of packet switching network where each packet gets routed. And so with packet switching, you don't have guaranteed bandwidth. So if you make a phone call over the internet, actually it's not that great at it, right? And yet, with the latest iteration of LTE, we do use the internet as the basic infrastructure. We use internet protocol for the LTE protocol and building it on top of it. And so I think that there's sort of this coming full circle where you can make some decisions that make it really good for some novel use cases early on, and then make it worse for some existing use cases, but then eventually the system gets ubiquitous enough that it's worth taking the downsides in order to get the sort of ubiquity of it. And so the way I would kind of think about Interledger is, yes, because of the splitting up, it's not great right now for making a $10 million payment, because there's a lot that could happen between when you start the payment and when it finishes, and so because you don't have that atomicity, but at the same time, you're not tying up any liquidity, the market liquidity can react to you, and so it's actually very good for any kind of smaller payments, or if you're sending a payment in such a way that you mostly care about the price of how much it costs to get there, so it would include a lot of remittance type stuff. And you can always kind of like pause the payment and kind of resume whenever the connectivity is restored, and then kind of finish it. So it's definitely very different from existing payment systems, and so probably has some different use cases, especially initially. Set up. Yep. All right, you ready? All right, we'll do one more question.
What's in the packet?
So the question is, what's in the packet? So the Interledger packet has an amount. So that's basically a integer that's kind of expressed in units that each link.
Milligrams of sodium amounts to 0.75. Sorry.
That's good to know. Where was I? What's the question? Oh yeah, the amount. Yeah. Okay, so you have an amount, which is basically an integer that if you and I are peers on Interledger, we've agreed to settle in some asset. So we could be settling in Bitcoin or gummy bears or whatever. And so it would be that many units of that asset. And so if I forward a packet to someone else, I would adjust that number, basically maybe subtracting a fee, maybe converting it to a different unit. So at each switching point, you would do that. The second field would be the destination. The destination is very similar to an IP address. There's a couple design choices that we made slightly differently. The address space is almost infinite, it's huge, mostly because we are less concerned about the efficiency of each packet than if you're kind of sending data, you kind of want the packet to be very small. There is a data you can attach to the packet, so that's essentially meta information. And just like the internet, Interledger has sort of a layered architecture. So mostly that data is used by the protocol that sits on top of Interledger to do things like associate the different packets back together into one payment and so on. Now, if we were just trying to create another sort of data transfer mechanism, we'd be done now. Those are we could even get rid of the amount, but those are the fields you need for that. But because we're sending money, there's one more thing we need, because if we stop here, what could happen is I send this packet, now someone along the chain says, thanks for the money, I'll just keep it here. Why do I want to forward that? And so unlike the internet, where you have kind of incentive not to fail because your customer will be slightly mad at you, you would have this strong incentive to fail at least a little bit so you can make some money on the side. And so we need to fix that incentive, and so we use a very similar trick to what Lightning uses and other sort of atomic swap type things use, which is basically just a hash lock. So using that, we can tell that the packet got to the recipient. So we basically say, when I send a packet, no money moves initially, and then when it gets to the recipient generates a pre-image, and then that travels the opposite direction. And then as that pre-image hits each link, that's when an obligation to pay is actually created. And that way, if you fail on the way forward, it's like the internet, you just kind of denied service, your customer's gonna be mad at you. If you drop it on the way back, you've created an obligation to pay out to your peer, but you're not gonna create the obligation to get paid back. So you have actually a strong incentive not to fail. And so in order to support that, there's two more fields in the packet. One is this pre-image, sorry, not the pre-image, but the hash of the pre-image. And then an expiry date. So if you don't show me the pre-image by this date, the whole thing is called off.
What is this exchange rate established?
So the question is, how is the exchange rate established? That's a fantastic question, because that is something where we went down ultra deep rat holes for years and years trying to design this protocol, and ended up getting rid of it entirely. And I'll explain how that ended up working. So we first had this protocol called the Interledger Quoting Protocol, ILQP. And what ILQP would do is it would send a special kind of packet where everybody along the chain would kind of put in their rates and then kind of forward it, and then the next person would put in their rates and then would forward it, and so on. And so by the time you get to the recipient, you kind of have the total rates along the path, and the recipient just needs to send it back and kind of say this is what happened. And then there were a couple different versions of the protocol even, where sometimes you want to quote by source amount, so you want to keep the source amount fixed, and then you wonder how much would get there. Sometimes you want to keep the destination amount fixed. We need to get exactly this amount there, and how much do I need to pay to make that happen? And then also, there was a third, even more complicated mode, which I won't get into. And so after a while, when we started to think more about these streaming payments and started to learn more about how TCP works on the internet side, you started to think about well, couldn't we just send a little bit of money and just see how much gets there? Because if all the packets are these small packets, what'll happen to the first one is probably pretty similar to what'll happen to most of the other ones, right? And so now what it does is it sends packets one at a time, monitors how much gets there, adjusts the amounts a little bit, and then basically monitors that the exchange rate stays within a certain window. So that's kind of what it does. After the first couple of packets, it has like a sense of what the exchange rate is, how much it would need to send. You can also use that as a way to quote. You basically just send a packet that the recipient doesn't fulfill, they just reject it. So it gets there and they don't provide the pre-image, so it just times out. Or they can actually actively reject it. And so that way you can even like probe without sending any money and see how much would get there. So that's kind of like a little bit on how that works. But the actual like details of the stream protocol, which is the sort of TCP equivalent, gets fairly complicated. So I'm not gonna have time to talk too much more of it.
So the receiver establishes the rate, essentially. Right?
No, it's more like you testing the rate, right? It's kind of like if you want to know, like you could ask everybody what the rate is. That was what LQP did, or you can just test. You can just send a test payment basically and see how much gets there. And that turns out to be, quite nice because now it's actually much harder for anyone to lie about what the rate is as well, because you might be actually sending a packet, and so you don't know if it's a test payment or not. All right, do you want to take over?
Sure.
All right.
Hi, I'm Ben Sharafian. I work at Coil with Stefan. And so all this stuff that he's been talking about, I'm now going to be able to show you some of it actually working.
And by some you mean all.
All of it, yes. Yeah, so Coil it's a company that we started recently, and we're kind of building on top of Interledger. So Stefan was talking about the web and its business model. That's what Coil's going after. And so we're using the Interledger technology to solve that problem. And so what that amounts to is we're giving your browser the ability to use Interledger. And so when you go to a website, instead of them sending you some ads, you can establish an Interledger connection to that website and actually send them money while you're viewing the page. And so here's an example of that working. And this is going to be an actual Interledger payment, which may or may not work. This is a mock-up site I made called a premium photo gallery, where a normal site may use something like a paywall where you have to register with them, go through a checkout flow. This just uses Interledger for a payment. So if I want to click this image of some premium pine needles, I can click it, it'll pay through Interledger and actually stream that money over there by chunking it up into packets over the Interledger network, and then we receive our image. So this is just one of the uses of it though. And what I'll show you next is it's an application from somebody in the Interledger community made. And it's called XRP Tipbot. It's very popular, used among the XRP community specifically, but we've talked to him and he's actually integrated Interledger as well. So now it's sort of also the Interledger Tipbot. And so just sort of to show you how an Interledger payment looks, like how you can do it through these different means. We saw it in the browser, but I can also just take my identifier in Interledger that this application has given me, and then I can I can go and this might be a little bit small on the command line, but let's see, there we go. So I'll just send some money to this XRP Tipbot application, and it'll detect that payment that it received via Interledger. So you don't have to just use it to replace advertising. You can also use it for some applications that wouldn't work at all otherwise. Like, an application where payments are pretty deeply integrated into it. And additionally, I can even go and say, I can give somebody my personal XRP Tipbot page if I want to maybe link this on one of my projects, say you can donate to me here. And anybody who goes to this page and is enabled for web monetization, which is, that's if you have a Coil subscription, which I can talk about later, then you'll be web monetization enabled. Anybody who goes to this page is actually paying you in the background.
Maybe a good time to kind of talk a little bit about web monetization.
Yeah, definitely.
Cool. So there's a couple of I think, dots we have to connect for you guys here. And I'll go to questions in a second, but I think there's a couple points I want to make first. So one, we kind of talked about, hey, we have these web requests where we request a page and then we get a response. Now we want to add money to that. We've talked about Interledger. Now the standard that brings both of those together is called web monetization. So that's basically, it would be a browser spec, so it would be something that browsers would implement, Chrome, Firefox, and so on. And it would allow a website to tell the browser, hey, please open a payment socket to me. And so we spent quite a lot of time thinking about what would that have to look like, and how would you do that? So the first thing you kind of notice is that if you're going to go to lots of different websites, you kind of want it to be in the background. Like if I'm making 1,000 payments in a day, I don't want to approve 1,000 payments in a day. It would drive me crazy. I go to each website, it's like, hey, would you want to pay? Yes, I want to pay. You want to read this? Yes. You want to watch this video? Yes. I want to watch this video? Yes. And I'm just kind of constantly approving things. And so that kind of stumped us for a little bit, and then we started to think about, okay, well, the browser already manages a bunch of your scarce resources in terms of CPU, memory, and so on, and it kind of has rules for how to allocate that to different sites. Like for instance, a website that's in the background might not be able to use as much memory as one that's in the foreground, things like that. And so why can't we come up with some rules for these very small amounts of money that you're paying, and kind of automate that process? And that was kind of like, okay, well, that seems like a promising direction, but very quickly, it's like, okay, well, there's a lot of clickbait out there. There's a lot of people who are going to make unsavory websites that try to get as much money as possible. So how do you actually make that practical without the user having to take a big risk and potentially lose a lot of money? If they just tie their crypto wallet to their browser, that sounds like a terrible idea. So we were thinking about how to make it a little bit easier. And so we had an MVP of web monetization quite a while ago. I don't know when, it was a year ago almost? No, less than that long. Yeah, maybe whatever, a couple months ago, up to a year. And it was basically you would download MoneyD, which is sort of your main kind of Interledger uplink point. You can configure it to connect to some Interledger connector, and then if you have liquidity with that connector, you can send Interledger packets, and therefore you're connected to Interledger. And so we had that implemented with basically like a wallet, so you can tie it to your crypto account, and it would send crypto to settle anything you do through that link. What Coil is trying to do is it's trying to basically make that a lot more mainstreamable. So we want to make it so that anyone can just, without having to think about it, without having to do a lot of complicated work first, basically use web monetization, because ultimately it's only useful if a lot of your users can use it, and a lot of your users will only be using it if it's very easy to get onboarded and get started with it. And so what Coil is trying to do is it's trying to say, we're going to take all the risk from connecting to this website and paying this website is our risk. And how do we do that? Well, we say, you get a flat rate. You pay us a fixed amount per month. We don't care how many websites you go to. We don't care how much time you spend on them. You just pay us a fixed amount. And if you spend more time, we'll pay out more, similar to how if you use more bandwidth on your internet provider, they might have to pay more. But we think that over time and across customers, it'll more or less even out. And if somebody is genuinely browsing the web 24/7 and their mouse cursor moves 1 pixel every minute, we might block them or throw them off the platform. Question?
Would you say it's like the all-you-can-eat sushi of web monetization?
So the question is it like the all-you-can-eat sushi of web monetization? Yes, exactly. That's exactly what it is. We gave a presentation at Apple, and they called it the Amazon Prime for the whole internet. So there's the other, catchy way to put it. And so, yeah, the main thing is that web monetization, the underlying standard, is still open. So unlike a lot of other platforms, you don't have to adopt Coil. You don't have to use our product in order to use this. In fact, you could start your own competitor to Coil, which would be cool. Maybe don't get too eager with that, but you can, and we'll take you on. But yeah, the underlying system is just Interledger and it's an open browser API, so it's not tied to even any particular blockchain, right? So if you want to use it with Ethereum, there's some people who are going to talk about that in a minute on how you might do that. And so it really, it's intended to be as neutral as you can make it. Did I cover everything?
Yeah, sounds about right.
All right, any more questions on Coil or web monetization? Yeah.
Where would this stand with something like a centrally backed digital currency or like some other form of assets outside of just like your pure utility?
Yeah, so Interledger, let me see if I understand the question correctly. You asked like, could you use any kind of different assets?
Yeah, exactly.
Yeah, so Interledger really, there's only very few things that it cares about. It cares that the asset is somehow countable, so I can like send you a little bit and then send you a little bit more, and we can kind of keep track of that. That's almost it, pretty much. Like other than that, you know, you can settle in gummy bears, you can settle in cash and checks, you can settle with bank wires, you can settle.
It doesn't even really need to be countable.
Because with a Coil subscription, for instance, you just have a throughput, which is just some sort of number describing how much you can send per second, but it's never actually settled. So really, it can be kind of anything.
Yeah.
On the receiving side, you probably care more about it being an asset that you want, but you know, the way that Interledger works is that the receiver can just pick whatever asset they want to receive, and they'll just end up with it. It'll be routed to them through the network.
Yeah, yeah, exactly. Does that answer your question?
So here's two questions. How does crypto actually add value here versus just $20 a month or whatever? And also, are you guys now building a database of every website I visit?
Okay, two very, very good questions. Number one, how does crypto add value? And number two, are you guys building a database of every website I visit? So I'll tackle the first one first because it's a little bit easier. Crypto, it allows us to, first of all, settle very efficiently and very often. And if you settle very often, that means that your risk is very low. So for instance, if you have a link that goes over XRP costs like less than a cent to make a transaction. And so you can very easily send like, 2 cents worth and then settle, and send another 2 cents worth and then settle. And so you're never really exposed for more than a tiny fraction of money. And so you can always have like a trustless link. Do you want to say something?
Yeah.
Although also the subscription itself, users buy that with just a credit card in dollars. So.
Boo.
Well, I mean, like the point of that is obviously to make it mainstreamable, right? Like we will obviously at some point accept crypto for subscriptions, but you know, the MVP for us is like we want this to be something that your grandma can use, and so it needs to be a credit card to start. And actually, like we'd love to accept Interledger payments for the subscription. So as there are more wallets that support Interledger, we'll definitely add support for Interledger payments for selling subscriptions as well. The second question, I don't want to forget about it, is whether we track or like what data do we keep around. And to be honest, like we are at a point where we're like trying to build our MVP, trying to get this launched at all. Right now, we don't keep a lot of data, and we keep the data that we need to settle with our peers on Interledger. So basically, like aggregate amounts of how much we're paying. We also will probably just legally have to track how much we're paying to each website. So for example, if a certain website is making more a certain amount, we have to get a W-9 from them. So that'll be fun. But basically the way that will work is like if you're a website that is doing a tremendous amount of business through web monetization, we may have to say at some point like, okay, we stop supporting or sending money to you unless you come back with your tax ID number, so then we'll start sending to you again. We'll figure out like what are the best compliant ways to do it. That's mostly like, you gotta comply, there's no two ways about it. Other than that, like on the user side, our goal is to be acting in the user's interest. The user's our customer. We don't have any advertisers. We don't have any other stakeholders. So really just it should be optimized for whatever the user wants. I hope I'll have a better answer for you as we get more clarity on how everything will work. But we want to do everything in the user's interest.
How's the experience on the user side? I'm assuming the browsers have to support the monetization, right? Which they don't right now.
Mm-hmm.
So is there a plugin or is it?
Do you want to talk about it?
Sure. So right now, the way it works is actually you don't need to install anything in your browser, because what we do is we pull in a polyfill. And so basically you have this polyfill script that the web page pulls in, and in that polyfill's local storage it says your web monetization provider is Coil, so we'll send Interledger packets to Coil. And that means it also works on mobile, which is kind of cool. We have an extension too and that extension allows you to go to sites that don't even know about web monetization yet, and we can do special stuff to say, if you go to somebody's YouTube channel, we can pay to them via Interledger by looking up, who does this YouTube channel belong to, but.
So how does that work? I'm a little confused. So YouTube has to implement something, right?
Yeah, so there's a couple different tracks that we're pursuing, and again, it's like trying to be as pragmatic as we can, trying to get this like launched and out there. And so there are, obviously, if a website actively supports web monetization, all they would have to do is they have to put in the polyfill, and then that would connect to webmonetization.org, and we're still looking for somebody to run that. Could be someone like Mozilla or something like that. And so now you can use that domain's local storage to kind of connect what is your provider and what is the website you're visiting, and now make that connection. So it's basically an iframe you're talking to. And because that just uses open web standards, it works in any browser today, and you don't need to install any extension. However, there's a couple limitations to that approach, at least in its current iteration. Some of those might be fixable in future versions of the polyfill, but for instance, you don't get any visual feedback right now that the website is being paid. And so that's a pretty bad user experience. And so what we said on our end is, for now, we recommend you install the extension so that you know what's going on. And so the extension can kind of give you feedback like, oh, I'm paying, I'm not paying, and so on. The other reason for having an extension is, if you're talking about websites like YouTube, a lot of the creators that you'd most want to support with something about monetization are on platforms like YouTube. If we wait until YouTube supports web monetization, we'll be waiting for a very long time. And so we were thinking about like, well, could you have some sort of extension that basically injects the right scripts into YouTube that would pretend that YouTube is web monetization enabled. And so that's something we're experimenting with, and we'll kind of see where that goes. That is a little bit like reliant on us in terms of how it works. Hopefully it'll be a stopgap. It's not something that we plan on running forever, but you have to get it to a point where YouTube is actually interested in supporting this natively. We just came out of a 3-year process of getting a new standard into browsers. So my colleague Adrian, he's a co-chair of the Web Payments Working Group, and so we spent the last 3 years working with the Mozilla guys and Chrome guys on the Web Payment Request API and the Web Payment Handler API. Both are now launched in Chrome, and they are on track to launch in Firefox and some of the other browsers. And that took about 3 years altogether, right? And so we expect that when we gather together again in 3 years, hopefully web monetization will be a native API, and a lot of those ugly workarounds will have gone away. But in the meantime, its extensions is our best bet and polyfills.
Yeah, so I'm a huge believer in ILP. I think the tech is amazing. It's going to change everything. I'm a little, I guess, more skeptical on the business side of this. You led off with a slide about the New York Times, a huge ad. But reality is practically no one goes to the NewYorkTimes.com, which is why they're trying to find other solutions to increase engagement. And all the engagement happens on social media. And when you're on social media, the ads are more, I don't know if ad blockers block that stuff, but the ads are in line and it's sort of a different experience. The ads are getting super smart and almost creepy. They know what you want before you want it. And so I'm just wondering if there's a different angle here, because like some guys, crazy guys in the blockchain space, like yours truly, we're trying to incentivize people with the blockchain rewards. And so I'm just wondering how this fits into where all the ads are, right? They're all on Facebook, they're all on Instagram. So how does this fit into that?
Yeah, so there's a lot there, so let me try to unpack that question a little bit. And I'm not going to repeat everything because it'll take a while. But essentially, we're talking about, what are kind of the websites that might adopt this? How do you get them to adopt it? And a lot of that is going to be a matter of experimentation. We're not going to go in and say we need the New York Times and these guys and the Washington Post and so on, and then we're good. I think it's going to be a lot more of we launch some project, we see how it goes, we see if anyone uses it. If people don't use it, we try something else. Personally, if you want to hear my personal prediction, I'm very excited about applications that are very difficult to build otherwise. So not necessarily content so much as interactive applications and content. So think of an example that might exist today is like an app that lets you edit photos on the web or something like that. And there's actually one I used recently, and I just wanted to use like some filter or something like that. And they made me go through like a sign-up flow, and I had to pay like $3, and then I had to worry about unsubscribing and all that kind of stuff. Whereas like with web monetization, it would be very viable to build an app like that and just say like, hey, as long as you have the app open, it's paying to it, and then when you close it, it stops, you know, and then I'm just making money on the traffic I get to that app. So that's kind of the use case I'm most excited about. Can you open Cody's host real quick? So there's a project that we did a little while ago, which is basically like sort of an MVP of a hosting network. And we'll see how far this goes. We obviously only have so much time to like, you know, support tons of different open source projects, but the basic idea is that it's just, you have a server where you currently use a technology called Hyper, which is basically Docker containers running each in their own virtual machine. And so all Codius is basically a piece of software that lets you, run one of those containers and pay for it with Interledger. And so we just released the software. We created a bit of a gossip network so you could like find out where all the Codius hosts are. And then now you can like upload a super heavily distributed application. So for example, if you want to launch your own blockchain, like now you don't have to go find validators, you can just upload it to a bunch of them and pay for it with Interledger. And so that's kind of like an example of an application. Now, how does this relate to web monetization? Well, you could build an app on top of this and on top of web monetization, where you basically say like, let's say you want to have a virtual machine that runs in your browser, or like you can start it from your browser and you use it to try out, you know, some distributed system, or you want to like have an environment that you can like destroy after you're done. Maybe you want to run some code you don't trust or something like that. And so now we can have an application that basically ties into web monetization to get the user's ability to pay for something, and then without any kind of buffer, like, you know, taking the money from the user and then holding it in a wallet somewhere, it actually has the user pay for the host that it wants to upload something to. And that all happens in your browser. And that's something that would be possible if you combine these two technologies. So you could have basically a website you go to, and then it spins up a VM and you're immediately in the VM just because your browser is web monetization enabled. And I don't know, it's just an example of an application that would be very different without web monetization. And so I'm mostly excited about seeing like if people can come up with different applications they can build with this.
So I had the opportunity to work with Evan Schwartz this summer on the spring team at Ripple, and one thing that always kept coming up is like, what makes ILP different from something like Cosmos or Polkadot, for example? I know that I guess maybe what you guys are working on is strictly focused on payments, but just from like your opinion, what would you say is like the core difference?
So I'll repeat the question for the recording. What's the difference between Interledger and other approaches to interoperability? And I think the thing I most notice is that unlike the other approaches, Interledger is very much optimized for simplicity. It's like we want to standardize as little as possible so that people can innovate on as much as possible. Like if you think you can make an asset that has better anonymity, it should be up to you to create a portion of the Interledger network that works a certain way where it guarantees very high levels of anonymity. If you want to make a really, really fast kind of protocol, you should be able to modify it in your corner of the network and still be interoperable with everything else. And so the internet has that property where the internet protocol itself is just like a couple of headers that you attach to some binary data and then you fire it off. And you know, that's really it. There's a lot of routing stuff that is a little bit opinionated, but as far as like the interoperability of sending a packet, like if you're configuring your home network with a routing table, you can send a packet through that, and the only thing you have to really adhere to is the header format, right? And so Interledger is very similar. It's like, you know, Ben gives this example of like, you know, Coil is kind of like an Interledger connectivity where you pay on a subscription basis, like the all-you-can-eat model. You could have another connection where you literally pay with like a bank transfer. That's like how we get uplink into Interledger. There's a company we work with that we have a relationship with, and then we basically pay them every once in a while. And there's all kinds of different ways that you could connect. And so Yeah, we just want to make it so that there's like as much flexibility as possible so that there's a ton of competition for making it better and faster. Just like with the internet where like constantly a new network standard comes out that's a little bit faster, people deploy it in different parts over time. We want the same thing to happen with Interledger. We're like, hey, I'm making a slightly better token, I'm making a slightly better blockchain, I'm making a slightly better ledger. I can immediately use any app and I can immediately talk to anyone on the entire network. All right. Should we bring up our friends from Ethereum plugin? You ready?
Yeah, I'm ready. You guys ready?
All right.
First off, thanks to Ben and Stefan. That was a really good introduction to ILP. I hope I don't reintroduce too much, but I am going to give you a background intuition of like why I work on ILP, what I think is interesting about ILP that's maybe different than what they think is interesting about ILP. That's kind of what's great about open source projects. And then we'll dive in at the intuition and technical level of like, what does it look like integrating a different cryptocurrency into ILP? What were some of the processes we went through that, and what are the lessons we've begun to learn can maybe pass on to people who might want to do future development along these lines. All right, so it looks like we can see my screen.
Can you do an intro of you first?
Sure, I'm Kevin. I work for a company called Kava Labs that's really interested in blockchain interoperability, like essentially fast finality blockchains. The notion that if we want blockchains to scale very well, they need to provide a means of payment in systems like ILP. If I have to wait 10 minutes for payments to clear as like the standard, the gold standard for cryptocurrency, it might not work for consumer adoption. And just exploring the design space around that is like really where we're focused right now. All right, let's see if I can present. Cool. All right, so I've been working around ILP for maybe 6 months and then thinking about this issue of like interoperation in the context of cryptocurrencies for like a year. And I actually think the answer to the question for me of why is ILP interesting boils down to like one fairly confusing sentence, which is that ILP can interoperate heterogeneous base layers. And so in general, like that's just like a pretty random statement. It's like, okay, sure. And so let me try to give you an intuition of like why I think that's actually very important and very interesting property and why it's different than other things. So first, let's start with this concept of heterogeneous. What might we mean when we say that, both in like the cryptocurrency world, the people who think about base layers in a very particular way, as well as the general world. So first, like heterogeneous in the cryptocurrency world often refers to essentially different virtual machines, Bitcoin script, EVM, a lot of development around other virtual machines going on, or consensus mechanisms, so Nakamoto, BFT, federated, centralized. Any of these things like make fundamental incompatibilities between systems at the level of communication. There's no notion of like me firing off an Ethereum transaction that talks to the Bitcoin blockchain. We can achieve, and we'll talk about this, like some workarounds that are kind of similar to that intuition, but there isn't really like I translate this opcode into that, now we're talking and everything works well. And this relates not only to like the virtual machine, but to the fact that like these things operate at different timescales. One has to wait for another and kind of be aware about a lot of information. And it's probably an unrealistic assumption to assume that any blockchain can do that with any other blockchain. And then, as I said, different definitions of finality. So we may have probabilistic, subjective, different timescales that these things operate on as well. All right, so then the second question is like, what did I actually mean when I said interoperate? And this is like a much more open question in the blockchain community right now. So we could say that two things are interoperating via a number of different definitions, and I think ILP actually takes a very, very interesting one if you think about it at a high level. The first is like, we could do asset issuance by trusted nodes, so I could say, I've got some BTC here, I'm gonna issue it on Stellar or some DEX, and now Stellar and BTC are interoperating via my BTC on that layer. That's like one approach. We kind of have to coordinate around a DEX if we want to do that. Like siloed liquidity is a pretty big problem if you think about that. direct base layer communication, so we can do like atomic swaps. I know there's people here who know a lot about Cosmos. So Cosmos is another, like IBC is another flavor of interoperability, and that says essentially like, let's take two zones, call them blockchains, have them communicate through a hub that minimizes your like routing considerations and centralizes the place where quote unquote trust is located. That's like an interesting model that's been proposed at the blockchain to blockchain layer. And then leveraging layer 2 and smart contracts, so we can do like submarine swaps. It's something that Alex Bosworth is working on with Lightning, where like I can take the hash of a Lightning payment and make it conditional on something in an Ethereum smart contract, and now I'm kind of like swapping a Lightning payment automatically for ETH. The problem is like that's kind of on chain in the case of Ethereum, and it's still like very siloed in terms of how you could present that. And what's ultimately like very fascinating is ILP's like credit question mark is the answer to like what does interoperability mean in ILP's case. And what's interesting about this is at first it seems like you're not interoperating, but when you start building on these systems, you realize that like oftentimes credit and fast settlement combined provide a user experience of interoperability for applications of payment and value transfer that is more effective than anything else in terms of how liquidity and how much liquidity you can put in that system and how that system might evolve from a perspective of decentralization. All right, so here let's like just get a brief intuition of why like ILP does what it does and what exactly it does. So we have Alice and Bob. They're going to make a payment over ILP, and they're going to use an ILP connector to do so. You'll notice that there's no settlement layer here involved. I'm not saying that they're exchanging value with one another. What they're actually doing is they're creating ILP prepare packets, which we talked about. They just have an amount and a condition and various header information. And she sends that to Bob, and they've communicated a preimage to a hash out of band. And Bob can reveal that preimage, and we can create an ILP fulfill, and that adjusts balances between Alice and Bob. And by this I mean balances as in like a record kept between counterparties. It's not a settlement on two ledgers. It's like Alice is owing the connector some money, the connector is owing Bob some money, and in essence we've completed a payment cycle that kind of reels in the payment. And so what this says is like, basically we can create a lot of very interesting things where we change our assumption from trust no one to create credit between bilateral parties. And what that does is it says that if I'm sending a payment 5 hops away, I no longer need to care about what happens between intermediaries 3 and 4. I'm only concerned what happens between me and my immediate counterparty, and we can meter credit between one another when we do that. And what's interesting about that is like that's basically how the real world works. People who don't trust each other don't extend very much credit, but people who do trust each other actually extend each other enormous amounts of credit, and it's very efficient in systems, especially payment systems. If you study them, one of the big critiques of like a blockchain-backed payment system is that collateral levels are often over 100%, whereas like modern payment systems are often using 1/6 the amount of collateral relative to payments that they're clearing. And so like the long-range scalability of a system kind of relies on credit. And assuming that like trust no one should be the base layer assumption of a payment system is very, very unlikely from my perspective. All right, so why credit? Great question. It separates the adjustment of balance from the settlement of balance. So I can have an account with you and it can say I owe you $100, but it doesn't mandate that like I settle that $100 immediately, and it doesn't actually care what units we use. So I could use different units with you than I use with you, and that's the notion of interoperability in this system. It scales independent of the settlement layer, and it's useful for value transfer as opposed to state transfer. And so this is something that like if you're very familiar with the blockchain world, we might want to be doing state safe transitions between people. ILP is more useful for like value transfer. So if we're building up some accounting record with one another, we can settle it with one transaction. It doesn't matter what the balance was at time I+2. I only care about the time when I settled. And so that's like a difference that you'll see between something like Cosmos and ILP. Cosmos might want to keep a record of the full transaction, all the history, and know like at time T what was going on here. ILP breaks that down, says this was the payment or this was the settlement amount that was cleared. All right, so like what's the difference between an ILP credit network and credit networks as we traditionally think of them? So credit networks traditionally permissioned, highly permissioned. You usually have to pay a fee. You have to maintain like status as a member to get into credit networks. And there aren't very many of them. High barrier to entry, low innovation, very few players in that scene, and it kind of makes sense. It's a big network. Once you build up a network effect, that's like the moat that you're defending. ILP like asks the question, or kind of has designed an answer to this: what would an open permissionless credit system look like? And the answer is like, there's a number of protocols that they've thought of that are kind of like the internet of credit. And so what this gets to is like, this is a new credit system. It's going to have different properties. It's going to be optimized for different things than today's credit system, but it probably has a very different application, an interesting application space that we're just starting to explore. All right, so ILP development today, like what are we doing with ILP? Because it sounds pretty cool. The answer is more currencies. So the reference implementation is written for XRP. One of ILP's like most interesting things is that we can denominate ILP packets in anything, and we can use connectors to create and synthesize rates and forward them. So we want to do that. We want to see what ILP looks like in a cross-currency world. By adding more credit into the system in denominating different assets, we can see like what are the merits and limitations of an open credit system as an interoperability solution and a permissionless credit system. And so like what's one like immediate application that you can think of in a cross-currency world is like, there's a lot of dApps that require you to pay in a token. There's a lot of processes in blockchain that like it's hypothesized you'll have to pay in a native token in order to maintain the network. It's unlikely that users are all that excited about this. Having 50 tokens in your wallet is quite annoying. Having to hold them proportional and worry about them changing in value is not very compelling. We think it's likely that ILP or some notion of ILP with a connector in the middle will allow you to pay in with what you want, get access to the network that you're attempting to access, and then not worry about the token conversion. You essentially get like at the last second access to these networks that are essentially guarded by a token. And so we can pay in with a number of things, pay out in a number of things, and use any intermediate currencies that are necessary. All right, so we wanted to create an additional plugin for ILP. It sounds like an easy process, but it's not super straightforward the first time you do it. It's a little bit more than you think. It's a pretty deep stack. So what's in a plugin at like a very high level? So a plugin is a way to send money between people in ILP because ILP doesn't care how you send money. So you need a plugin to say, we're gonna settle money over this asset. So the first thing we need is a way to communicate and acknowledge messages. So they have a protocol called ILP plugin BTP, the Bilateral Transfer Protocol. So me and another person can exchange messages over WebSockets in an authenticated manner. And we can do so with like a call and acknowledgement as opposed to just one-way messages. This is important for ILP because like if I sent you money, I want you to acknowledge it, or I want it to knowingly fail. A way to manage accounts and balances. So one of the things that's interesting about ILP that we didn't talk about in the Coil setting, but is generally true of the protocol is like, in the case of payment channels, I can create a connector. You can show up to me with just your address and putting money in a payment channel, and I'll forward payments for you. So I've actually taken no information about you other than your pseudonymous public key. And we do this with this notion of streaming payments. If I'm sending money through a payment channel in one direction, out another direction, I can do so in a very trust minimized manner. You can send me 1 penny, I can send 1 penny out, you can send 1 penny again, and we can do this for some amount of money that's not insignificant, that can actually move a decent amount of money because in payment channels, we're just passing messages back and forth. And so this is the last part. We have to actually send the money. So we can create accounts for one another. I can associate your public key with an Interledger address, but I also need to be able to ask you to send me money or for asking you to forward a packet for me that will adjust our balance. All right, so why ETH? The first thing is that it's very different than the XRP ledger. So even though ILP is not opinionated, plugins are going to be opinionated about how they operate, how often they want to use on-chain transactions, how expensive an on-chain transaction might be, how slow an on-chain transaction might be. All these things are different between different currencies. ETH is a good contrast, so it kind of requires a different design paradigm. It's widely used by cryptocurrency standards. It's a little bit cheaper than Bitcoin typically in terms of transaction fees, so it's somewhat more likely to be used for particular applications, although nothing is heavily used right now. The EVM is popular and payment channel implementations exist for it. So one of the things that's important for ILP is like we try to keep the payment channel libraries minimal. We don't want payment channels to add a layer of complexity in terms of like failure of routing or whatever, so we tend to use unidirectional payment channels between you and a connector. And there's very nice implementations written on the EVM. The one that we use is called Machinimi, smart contract written by a guy named Sergey. And pretty minimal functionality in the smart contract. I create a payment channel with my counterparty one way. I send them payments, they can claim them at any time on chain, or they can let their balance build up. And then if my counterparty disappears, I can initiate a settlement dispute. Number of blocks you have to wait, and then I can claim the whole fund. It's a pretty standard, like unidirectional payment channel model. It's been reasonably well used, so we feel comfortable using it. And what's really nice is it extends to ERC20 tokens with minimal changes. So if this plugin works, we can make a few changes to the API call. We can use it with any ERC20 token, and now we can add hundreds of tokens into the ILP network very quickly. All right, so what are the actual considerations that came up as we were doing this? It took us about 4 weeks from like first draft to getting something more or less working. So the things that became important is like on-chain transactions are slow and potentially expensive. So you really want to like minimize the number that you're doing relative to liquidity. I can't force you to put more money in a payment channel, but I certainly can like suggest that when we do on-chain transactions, we check how expensive they are and that we try and make a minimal number of them. And then of course, payment channels are going to speed that up. So when I have money in a payment channel, I can like simulate settlement by sending a payment channel message, but I have to have enough liquidity. And so this is a big like trade-off that you make in terms of, do I want to put $10 in a payment channel and have $10 of fast settlement, or do I want to put $100 in a payment channel and have $100 of fast settlement? And then another difference between XRP and ETH is there's no built-in spam protection to the ETH network. Ripple, or XRP, sorry, has a minimum balance amount. And so like you're not going to be able to create an infinite number of accounts and try and like connect to people over and over again. And so we had to think about like what's the best way to do this where I don't want to take additional information about a user, but I also don't want to get spammed easily at least. So what were the key design choices and intuitions that came up? So this was a big one. In the notion of a balance in ILP, we're building up credit plus or minus with individuals. We kind of have 4 variables that are important to think about. We have a max balance. This is the maximum amount that I'm comfortable being owed. So I'm building up a balance. I'm like, great, I'm going to get some money, and at some point I'm like, ooh, that's a lot of money. I really hope this person doesn't run away. Same in the minimum. This is kind of the reverse of that. I'm owing somebody, and at some point I'm like, that's a lot of money. I should probably pay them. And what's interesting about ILPs, we don't know in advance what our peer has set. And so if I've said, I'm willing to go negative infinity to you, this is great. Most likely my peer is going to be like, actually, I'm not cool with that. So having like a sensible intuition for that is important. And then these 2 things in the middle is what like keeps the magic flowing. So settle to and settle threshold. At some point I'm like building up a negative balance. I owe you money. I hit this thing called settle threshold, and it's like call attempt settle. And what it wants to do is like get my credit back up to some number. Usually it's 0, but just for the graphic, it's a little bit easier to see. So I want to settle back to 0 because I'm like, I don't want to owe you money anymore. What's important is that this isn't not only an async call. In blockchain land, this could be like an infinitely long async call or like a 10-minute async call because we need to do an on-chain transaction and get it confirmed. And so I need to have the delta between settle threshold and min make it at least somewhat likely that I can keep clearing packets for a while before I have enough balance to settle to. And this is still like an open question, but as you can see, like just through intuition, you need more liquidity here in your payment channels and in your credit extension if you want to have a good time. Otherwise, you're going to end up waiting for on-chain transactions to occur forever. All right, so we're going to do a quick demo. First, I'm going to run through the repo just to give you an intuition of how it looks and how it's set up and why it's set up, and then we're going to do a demo. So today what we can do is pretty simple, like Alice can send Beth through a connector some ETH. Not that interesting, but pretty quickly you can start to swap out assets and you can do cross-currency stuff. And like this is the notion of a DEX right here. Like if Alice is sending money over Ethereum and receiving an XRP to herself, she's like swapping assets the way that DEXs would. And what's interesting about ILP is that like if there's multiple providers here, we have kind of a pooled liquidity set up. As well as like if this is an app right here, Alice can pay in an ETH and get access to the app and whatever the app token requires. So we're pretty close to this level of functionality. How well it will work, open question. All right, so here we are. So the main abstraction that we ended up using in order to create this is an account. So it turns out that what we're really like interested in doing is creating an account. If we're a client or AKA a sender of payments or a receiver of payments, we only care about our own account. If we're a facilitator of payments, basically a connector, we want to create accounts for our clients and we want to manage our own account. So in an account, we want to have all the functionality that we need. Internet here is a bit sketchy. We'll see if we can do this. All right. So we want to know the status of the account. Is it settling? What's its balance? And what's its Ethereum address? And so the main intuition here is like somebody shows up with an Ethereum address and they communicate it over BTP and that gets hashed to an account. And now the server is keeping track of that account and I'm keeping track of my own account as a client. And then a server essentially implements the mini accounts abstraction. So it says, I create an account for myself and anyone else who shows up, I create them an account as well. And the only rule is that one Ethereum address per account. You can't show up, use the same payment channel in two accounts. It would be tough to prevent double spends in that case, because they could give you valid claims on multiple accounts. So I create an account for you if I don't have one, and I basically keep track whenever I get a payment. And then I create a WebSocket connection between me and you to communicate. And that's like the main abstraction. And so then inside the thing, we're just wrapping all of this up to create a WebSocket server and all of the Ethereum essentials that we need. And so in the demo, what we're gonna do is we're gonna have 3 Ethereum accounts. We're gonna have account A, account B, and account C. B is the connector, A is the sender, C is the receiver. And how you'll think about this happening is the server demands a very tiny amount of prepayment in order to get this relationship started. So Alice funds a payment channel. That doesn't change anyone's balance. Alice still has control over assets. But Bob says, you have to send me a payment channel claim for enough to close this channel, because otherwise you can spam me by just creating payment channels, and then I'm not really sure if you're gonna make it profitable to me. So you could send like a tiny bit amount of money, less than a closing transaction, and then I could forward a payment on the other end, and it wouldn't even be profitable for me to claim the channel. So I'm gonna basically demand that you pay the closing cost of the channel up front, and then enough to send a single packet of payment. On the outgoing way, person who's receiving here, account C, when their balance builds up enough to cover a transaction fee, I just open a payment channel to them and send off the remainder. So I don't need to have any existing relationship with this person. That's what's kind of interesting about unidirectional payment channels. As long as I have their account, I can create a payment channel to them without asking their permission, and I can build up a balance for them and they can receive that balance. Now, obviously, like, you wanna do this still like with a known counterparty here, because otherwise they can tie your liquidity up. But in terms of just like receiving on the Interledger network, this person never had to sign up for any particular service with this person. They just had to be online and able to claim their funds when they needed to. All right, so now we're gonna see a bunch of rough output from the terminal, but hopefully it will add up on Etherscan to a story that makes sense. As I said, the internet here is a bit sketchy, so I'm not guaranteeing anything. We're gonna try. All right, so we create these accounts between people, and then the first thing that happens is this person has no channel, so they need to attempt to create a channel. And we will see if the Kovan network is feeling cooperative.
Can you zoom in?
Oh. there a zoom tool?
You can just pinch.
Just do command plus.
Control plus.
Command plus.
Command plus. Yeah.
Okay, now so we're getting good messages now. So we're building up this balance, and let's just think about intuition here. Let's see, we had an insufficient funds. All right, insufficient funds to open a new channel. So this is like a unique feature of ETH, that if I'm trying to send you an amount and it's a small amount of money, it may not even be profitable to open a channel yet. So we have to allow enough credit to build up such that like it makes sense to open a channel. Eventually enough balance will, this is like what the notion of packet switching is. And so we'll eventually open up a channel. Let's see where we are. Okay, so now we're crediting accounts. As you can see, at some point, we need to do these deposit transactions in order to like refill our payments. So we can imagine that these people have like a standing relationship, and at some point, over a number of days or whatever, they've spent down their balance, and they're like, okay, you need to redeposit. The plugin will handle that for you, so we'll deposit more money into the channel, and then they can continue filling packets. And hopefully during that time, we had enough credit that we didn't just like stop fulfilling packets. That's like the delta between settle threshold and min. We're trying not to hit that. All right, and so like we're streaming payments throughout this, and at some point the person will want to settle. I'm not sure if we've gotten there yet, but we can look at Etherscan to see what's happening in the background here. So this is account A, and they're the sender. They're going to send to account B. And so they've sent money, and they're sending it to this contract here, and this contract is creating the payment channels. And so you can see they've done a number of transactions. The first one created a channel, that's what happened here, and then the second and further ones, we're calling the deposit method on that channel. And so that's like the sender. Here's the payment facilitator or the connector. So they have both received, well, they haven't received any transactions. All they've actually happened is that a payment channel has been provably open to them. They don't have any additional incoming transactions, but they're also facilitating outgoing payments. And so they're creating a channel now to person C, depositing additional balance when necessary when they've hit their settle threshold. And then person C is ultimately just going to be claiming, which it looks like they attempted to do and failed. That's not fun. Ran out of gas, interesting. And so person C now has this balance built up, and when they choose, they can settle the payment channel, and it will send money to them and to the other person. And so the notion of this is like, we can do this very easily. You can start to do this, and that's where we think like ILP gets very interesting. So, would love to hear questions. Otherwise, that's it for today.
So I have a tough time reconciling this in my head where ILP fits in, but how do you think about other payment channel networks like Liquidity Network or state channel networks like Seller and frameworks like Counterfactual? Are those separate things or?
Yep, so I would say that state channels are much more useful for self-contained applications. So something like Counterfactual, the notion is like I send my money to a signature account, and now I can like instantiate a whole application suite on top of that and like do things. A little bit unclear to me like what those things are, but maybe one day it'll be clear to me, like really want to play chess in a state channel or something, like we could do that. Whereas like you could maybe do that with ILP, but like unidirectional payment channels are kind of a solved problem in terms of like I don't think there's that much more optimization you can do. And so like I think the use cases for it is like we're probably going to prefer unidirectional payment channels for the foreseeable future, but that state channels mostly have their applications in terms of like application layer stuff.
you're streaming payments, right? You're
Yeah.
doing the same thing as state channels to a certain degree.
Yes, but we're building up tiny amounts of credit, which is the difference. And if two parties had a lot of credit, like we wouldn't be streaming very many payments, we'd just be adjusting balance. So it's kind of like, in terms of the credit efficiency, it's like you have a lever you can push, which says like we don't settle very often and it's actually more efficient, or we settle very often because I don't trust you. Other questions?
So the interoperability is only for ERC20 tokens, or do you guys can support?
Oh, we're gonna be building more plugins. Lightning is the next one, natural fit. And you know, any blockchain that supports payment channels is like a good candidate to integrate. The part of this process was like really getting down to the level of like, can we abstract this enough so that the next time I write a plugin it isn't as hard? And I think we're kind of like at that level now where we have a good mental model of it. All right, anybody else? Otherwise, I'm happy to let you go. All right, thank you.
All right, before we wrap up, if are you guys still like lucid and like want to hear some more stuff, or yeah? See some nods.
Yeah. Yes.
All right, cool. So let's call up Strata Lab. So I'll let them explain what they are, but the idea is we'll have a little bit of a chat with another company that works with ILP from yet another perspective. Yeah, if you bring one more chair, and I guess I'll sit in the middle and just kind of pass it. All right, so first, why don't you guys introduce Strata and what do you guys do? Who wants to?
So right now, Star Labs is just Dino and I, and our main service as a company is we're an Interledger service provider. So right now we've been working pretty closely with Kincaid, who's not here, but Kincaid and Kevin, and on the Ethereum plugin, and we've been focusing on the Bitcoin end of things. And our main service right now is just ensuring that people can connect to the network pretty easily and providing a service that actually can handle a decent amount of payments. Do you want to say more?
Yeah, I think a big part of ILP right now is kind of showing to people the capability and the potential of a technology like this. Like kind of addressed by that question, I think a lot of people have misconceptions about what's the difference between ILP, you know, and other state channel implementations or other technologies that are trying to do similar things. And what we're trying to do is kind of build some of the fundamental things so people can actually see those and use them.
Yeah, and I think like what's fascinating to me, and especially like now that there's more and more people working on it, is sort of seeing the complexity that exists in like the different subject matter areas. So for instance, like, you know, Kevin was showing sort of complexities with integrating with the ledger. I'm sure Ben could talk a long while about the complexity of integrating with XRP ledger. But what's cool is if I'm a developer building on ILP, I don't have to know about either of those. You know, and it's just kind of like, that's the benefit that I get out of it. Do you want to talk a little bit about what is the complexities in running a connector? What are the sort of challenges? What are the things that you guys worry about?
Yeah, for sure. I think one of the most important things in running a connector, we briefly kind of mentioned exchange rates. And it's pretty much, in this early stage, right now, you're not really worried about that. You kind of just want the network to be thriving and working. But soon enough, one of the things you have to keep track of is all these different currencies that are going to be a part of the connector. And the way you do that is kind of out of scope. So ILP defines you know, some minimal backends that pull rate information, but other than that, it's up to you how you actually handle those assets. So one of the early complexities that I think Austin and I dealt with, and it was actually before we really got into ILP, we were kind of building a miner trading system, and that's how we got into crypto really. And we realized this is really applicable for a connector and actually really necessary because you need to be able to, you know, price these assets appropriately and exchange them appropriately so you can make some money. Because if you're holding a ton of different coins and they're all really volatile, it kind of becomes difficult to reason about, you know, which assets you should be holding and which ones you should kind of only buy when you really need to send a payment or something. So I think that's an entirely different form of complexity from kind of what Kevin was talking about, because It's a lot more about financial knowledge and currency knowledge as opposed to kind of the fundamental technology at ILP.
Okay. Yeah, I have one or two more questions, and then we'll kind of open it up for you guys to ask a question. So you mentioned this term ILSP. Can you briefly define what that is, and how does it relate to the term connector? Is it interchangeable, or how do you think about it?
So connectors are the entities that basically provide the connections in the network, and an ILSP is a tier 1 connector. So tier 1 connectors provide the routing for different payments to go through the network. We're focusing on running a tier 1 connector. And one thing that we really would like as well is to grow the community, and because we want the network to be as decentralized as possible, so we really want to support tier 2 connectors to join the network and make that as easy as possible as well. So we're interested in growing the connector side of the network so that people can provide liquidity, and people developing applications, we want it to be as simple as possible so they don't need to think about connectors or routing payments when they just want to run a blog and write about stuff.
All right, let's get a little bit technical, because we build this as a technical meetup. We don't want to have people feel like we didn't go deep enough, although we've had enough console on the screen to hopefully allay those concerns. You talked a little bit about the real challenge is the sort of exchange of different assets. Can you walk me through what happens when you receive an ILP packet that's denominated in one asset and it has a destination where you have to send it out in another asset? Like, what happens in that actual case? Where do you source the liquidity? Just how, on a high level, how does it work?
Yeah, absolutely. So when I receive an ILP packet denominated in one kind of currency, we kind of spoke about how ILP packets are denominated in almost their own, there's ILP packets, and then you have different underlying currencies that have different asset skills. So, 1,000 ILP packets might be 1F, whereas like the equivalent on XRP is much less ILP packets. So the process is when I receive 1,000 ILP packets as a connector, let's say I'm exchanging from asset A to asset B, and asset B is valued lower than asset A. I'm going to essentially just decrease the number of ILP packets that I forward along to send less ILP packets. Correct?
Yeah, let's call it the amount, right? So
The
you're
amount.
lowering the amount. I think it's still one packet.
Lowering the amount that I forward overall. And during that process, one of the things that has to happen is you query the backend to get the rate on what this exchange rate might be. And where you query depends, it's up to the system. So in our case, we have an account on Kraken, so we're going to query the Kraken order book and see what the exchange rate for these two assets is. And we want to price it accordingly, so when the time comes, so we're holding both of those assets to be able to settle out in those specific currencies, but we want to price it accordingly, so when the time comes, we ideally made a profit or at least stayed even and didn't lose money on that exchange.
Perfect. Yeah, and I kind of wrap it up to talk about from our perspective as Coil, maintaining connectivity on the Interledger, it's actually like an active job. Like, you actually have to do work for that. You have to figure out like who to settle with, who to peer with, and so on. That makes the network very efficient because there's people actually thinking about like, this node charges too much, we'll probably start avoiding routing packets through them. But what that also means is that I don't want to do that all day. And so from Coil's perspective, like, we would love, or we like working with an ILSP that does all that for us. And again, I see a lot of parallels with that in the internet, where like, I'm not going to be my own tier 1 provider unless I'm like Google. For everyone else, like, I'm going to go to some internet service provider that's doing nothing but providing amazing internet connectivity, and I'm just going to hook into that. So that's kind of where when we were working on ILP, we just kept finding parallels to the internet, and it kept working, so we kept going that direction. So, are there any questions in the audience for Strata? Great.
I asked too many questions. Where do you maintain the credit balances? Where is the state kept?
So the question was, where's the state kept?
So the state for ILP packets is kept in a database. So in the case if you like launch a local connector, that might just be an in-memory store. If you're hosting a connector on the cloud, that might be something like SimpleDB on Amazon, on AWS, or a different database. But that's where you keep the state for the ILP balances. The state for the ledger-specific stuff is denominated in each of the plugins. So kind of like, if you're building a Bitcoin plugin, you might keep transaction state if that's important to you in a respective database or location. That's pretty important though too, because when let's say you open a payment channel to my connector, and something goes wrong with my state, you're going to have to probably open another payment channel to my connector, and that's a problem. So it's definitely, important for you to keep the state in an appropriate place. But that being said, when you do have a transaction, let's say we've opened a payment channel, that state is also maintained by the payment channel implementation itself. So you can only run the risk of losing the amount. Kevin was describing it as a credit lever. You can only run the risk of losing the amount that you've given me on that credit lever, or I've given you on the ILP network. But other than that, which is usually on the order of a cent or less.
Do you want to talk? Yeah, I was just going to say that is up to the person providing the service. So it provides flexibility if somebody just kind of, say they're a miner or something, they're sitting on a bunch of some coin and they want to run a connector. They probably don't want like a massively complex database to actually operate that connector. So they could just use a much more simple database than like what we'll be using.
Yeah, I think that's another kind of important general point about ILP is a connector is not the same as another connector. Like you could have a connector that is a company that's operated with 24/7 support, and that would be a kind of connector. And then you could have a connector that's much more like a home router. It's like me connecting a bunch of things together and just wiring them together, and it just kind of multiplexes everything into one upstream, ILP link that I have. Any other questions? Right here.
So I know with Plasma, a lot of the concern is like if you have a lot of exits all at the same time, do you guys have any, have you run into any circumstances that would be problematic, like with all these payment channels that you're running? Because you're leveraging like the trust that those payment channels are going to exit correctly, right?
So I'll repeat the question. So with something like Plasma, there could be a lot of exits, which sounds like that's like a closing a channel, a closing a channel. Yeah. And what if they happen all at the same time? So that I would say is like a question for the people integrating with each particular blockchain. So for instance, I could like call Kevin, do you want to come up real quick and talk about it from Ethereum's perspective? And this is also kind of something where from the protocol design perspective, we expect there to be a lot of innovation. So like if there's something of how I can change my chain or make a better chain that avoids that problem in some way, it could be supported, but I hand it off to you.
So the question related to like mass exits assumes that if you have a unidirectional channel, basically the receiver is the only person who can mass exit, and they would be doing it to themselves. So it's very unlikely, like in that case, that you would have a problem. The main thing is like if you have too much liquidity tied up, it could become annoying. Period. But in the case of Lightning, yeah, if you're operating tons of channels, there is like what I would call a tail risk, that essentially like if the network becomes unavailable, your collateral could be at risk. But that's like the default assumption of layer 2 solutions. And so there is like a lot of open questions around like how much can I store in layer 2 before like I'm at risk of some bad condition coming up, and now I'm not sure if I'm actually gonna get my collateral back.
And I sorry for keep repeating the same point, but that is so important to me as like an app developer. Like I don't have to worry about this, right? It's kind of like whatever solution people come up with, my app is going to be compatible with it. People are going to choose whatever works best for them. If you're an ILSP, you're going to think about like what settlement mechanisms do you want to support that don't put you at too much risk, and weighing that against like what your customers want. Like for instance, we had a negotiation of like how are we going to settle, right? Yeah. And so I mentioned that there would be a lot of those conversations happening as people try to get onto this network.
Yeah. One pretty interesting point in regards to that is, I think one of the really neat settlement mechanisms. Kevin was talking a lot about credit, and as a connector, you kind of have a fundamental decision of whether you expect your users to pay you beforehand, or whether you're willing to extend credit to at least some of your users or other users. And I think that that opens the door for a number of different business models and opportunities because people can kind of just sign up on your system, and the more that they use your connector, the bigger that trust expands and the more payments they can send through without having to think about the underlying ledgers, the settlement, or any of the excess costs. So it's kind of nice because we always think about, I think a lot of times in the blockchain space, people think about trust as this binary thing. Like it's gotta be, trustless or it's trustful. But in reality, this slider is like a really practical implementation towards that.
Right, there's a question in the back?
Yeah, I just, maybe if you could start, like, does the business model for an ILSP look like something, like a traditional ISP? Like, are you guys like a, like a CompuServe or an AOL of, like, to ISP, to ILP?
So I'll repeat the question real quick. So does the business model of an ILSP translate to what it would look like for an ISP, so an internet service provider?
So the two most obvious models to monetize as an Interledger service provider is the first, just taking a margin on any packet. Say we just host an endpoint that anybody can query and start a channel with us, we could just say take like 1% that goes through it. However, with more like enterprise clients, you can essentially charge in a way that's very similar to bandwidth. So they could just say, we want access to this much liquidity per month, and then they could pay a fixed rate amount to the Interledger service provider, and then we could provide that streaming payments actually on the network.
I think there's a few like slightly just like higher level like distinctions or kind of also similarities, actually distinctions and similarities. One of them is that there's kind of a necessity for cooperation, I think, in both ILSPs and internet service providers as well, where you expect, that the internet service providers around you are providing a service, and if they're not, it kind of damages the entire network. So that kind of reliance on other ILSPs that are doing their job as well is something that's, I think, similar and great for the network because it encourages, amongst competition, great cooperation too, because to build this network, everybody needs to work together. One difference is that we don't have to put down hardware yet until that's worthwhile, but I think that's, other than that, they're pretty similar. But ILSPs, one thing we were talking about recently actually is that they do have specialized hardware to scale for different things. So this company, Juniper, that makes routers, has 4 terabyte bandwidth routers for those applications, for the really big city blocks that need that. So in a similar case, ILSPs might have different connectors with different amount of liquidity for different use cases.
Yeah, that's one of the funny things that I like to think about sometimes. It's like, are we going to see some of the companies that are currently making ASICs for crypto mining, are they going to start making ASICs for Interledger routing? I think we'd have to get to quite a bit of scale to get there, but that's what's happening with the internet. Okay, one more chance to ask questions. I might open it up for basically anyone you've heard from, Ben, myself, these guys, Kevin, anyone you want to ask anything, now's your chance. Right? Otherwise, feel free to hang out. We're going to probably stick around for a little bit longer, but that concludes our scheduled programming, and thanks for coming. And also, massive thanks to Kevin, Dino, and Austin for speaking with us.